I have two arrows here face the same direction, but not really. They're actually facing the opposite direction. This happens because the speed of light slows down when it moves through high-density materials like water, causing refraction. But that can't be true, right? Does the speed of light actually slow down? Well, we can actually measure it using an iPhone. An iPhone measures distance using time-of-flight LiDAR with little infrared lasers shooting out the front. So if I just use an app that measures distance through a dense material and then through air, I should see a big difference. So let's see if that's true. I'll use the wall of my vacuum chamber here. I can still focus on the sticker shining through the whole length of the acrylic. First, when I just focus the sticker through the air, it gives me about 54.2 centimeters. But now when I do it through the acrylic, it gives me about 82 centimeters. That's a huge difference. So it would seem that the speed of light has actually slowed down significantly. In fact, I can calculate how much it has slowed down using the incorrect distance. The new speed of light is just the true distance divided by the incorrect distance times the actual speed of light. So if I just take 54.2 divided by 82, then I get the speed of light through the acrylic is only 66% of the actual speed of light. But how is this true? Isn't the speed of light a constant of the universe? How is it slowing down? Well, it only appears to be slowing down. Remember that light is electromagnetic waves that always move at the speed of light. When those waves hit the electrons in atoms, it causes those electrons to wiggle. Wiggling electrons make more electromagnetic waves. But these new waves output electromagnetic waves according to the derivative of the incoming wave. So it shifts from a sine wave to a cosine wave. When you add these two waves together, it's as though the whole wave shifted back a bit. This happens every time the incoming wave hits a new layer of atoms. So the result of this is a new wave that appears to have slowed down. But in reality, it's a bunch of waves all moving at the true speed of light, but the resulting wave is a waveform with a slower speed than the original waves. So we just say that light slows down in materials, and the denser the material, the more atoms it encounters, so the slower it moves. How cool would it be to slow down light so slow that you could beat it in a race?